Good evening and welcome to the September 25 meeting of BayLISA, Bay Area Installation Systems Administration User Group. My name is Mark Rovner. I'm the current president of BayLISA. And here with us today we have fellow board LISA members Guy Purcell, Peter Downs, Ron, Danny, and our Cisco representative and board member Adrian. Hey. Paul, oh yeah, Paul is here. Sorry. BayLISA is held on the third Thursday of every month, and its meetings are open to the public. We are a membership organization, so we do encourage people to join, but it's not required. Membership fees enable us to pay for various organizational expenses, like meetup.com fees, meeting refreshments, and such, so that we continue to bring you the best speakers and present you with interesting and relevant topics. If you or your organization would be interested to become a member, please speak with myself or one of the other board members, either after presentation or online. BayLISA would also like to thank Cisco for supporting BayLISA by arranging for us to hold our space here. Please be respectful of the facilities and remember to clean up after yourselves before you leave. There's still no Wi-Fi available here, right? Make sure, yeah, sorry. BayLISA is a volunteer organization, and as such, the board is always looking for new volunteers. If you enjoy these talks, we encourage you to give back to the community and help. It's not hard work, but many hands make the lift easier. The board meets on the first Tuesday of the month to make plans for a general meeting, discuss topics and speakers, and to generally make BayLISA better. But above all else, finding speakers is the most important task for the board. So even if you don't have time to volunteer, we're always interested to know what you want to hear from at future events. Maybe you have a subject you'd like to hear more about, or there's a specific speaker you'd like to hear from. Or maybe you yourself have a project or experience that you'd like to share with the community. If you feel this is something you would be interested in helping with, again, speak to one of the board members or myself, either after the meeting or online. We typically reserve a little bit of time for announcements. So to start us off, any board members with announcements? Cisco have any announcements?
Nope.
Okay. We try to tell you about upcoming tech events that are in the Bay Area and around. Coming in October, the PyTorch conference will be held up in San Francisco, says it's to the premier PyTorch framework conference. There will be deep dives, panels, workshops on AI from bare metal all the way up to applications and agent layers. Standard tickets are online now. Late starts after, well, start on the 12th. So if you're interested, you might need to accelerate taking up your boss and or your vendor to get a discount ticket. Isovalent is holding a half-day Oktoberfest workshop in Mountain View on October 16th at Stein's Beer Garden. There will be some Isovalent hands-on labs and a demo of Isovalent Network Bridge, and I'm assuming some combination of pretzels, beers, and brats. There's an RSVP to save a spot for yourself. All the things I'm mentioning, there are QR codes on the back wall for, and the URL if you're interested. Where Ron is racing over to. So if you're interested, make sure to take a picture of that. Ron's making sure he knows where the beer is. For those outside the immediate peninsula area, DevFest, hosted by the Google Developer Group, will be held Saturday, October 25th in Modesto. It's a free full-day tech conference where there will be speakers, workshops, demos for developers, innovators, and tech enthusiasts of all skill levels. That's a free event, but you have to sign up for it too. I believe that I have the QR there. While still ways off, Usenix SRECon's call for participation has opened, with a deadline for submissions being November 4th. If you have interesting experience or valuable knowledge that you'd like to share to the SRE community, well, first, why aren't you talking to us and sharing it here? But second of all, you have SRE is a great place to speak to a wide audience of people. Have yours submissions by November 4th. Finally, the Maker Faire Bay Area is next weekend. I've been mentioning this for months now. It's finally here. Billed as the world's largest show and tell, the fair combines DI worlds of science, tech, music, arts and crafts, food, and more. This year it's being held again up at the Mare Island Naval Shipyard in Vallejo, but time is running out to attend. This is something I take my daughters to all the time. They love it. It's great. If you have kids, it opens their minds to, not what they just learn in school, but what they can do with it. And it's a great event for techies like us, but I also feel the kids should be taken there if you have nieces, nephews, daughters, sons. Okay, so before we really get started, we ask you to please check your phones and put them on silent or vibrate. Many of us are part of on-call rotations, and so we understand you get paged. But if you have to take the call to minimize disruption, please take a step outside. So one of the current uses for large language models, AI, is the absorption of rote knowledge and then being able to answer questions on said knowledge. For SREs in particular, this can be a game changer, for we can now have an interactive FAQ that we can use to develop, manage, and maintain the systems we work with, and even automate some of the toil associated with them. So for tonight, please help me welcome Andrew Lee with his presentation, Agentic AI for SRE.
Do I need to use this? Can you guys hear me okay? Is this fine? Good volume? Live stream's good? Okay. Thank you for being here. And I didn't expect such a large crowd. And I haven't spoken to a crowd this large in a long time. So thanks for coming out. And I think we have a lot of distinguished guests today. At least one's from the East Coast. I met a gentleman from Japan here. Who's touring the state to look at different technology companies and tour different Apple campuses and Google campus. So welcome, and thank you again for being here. Thanks for the hosts for hosting this event, and thanks for allowing me to speak at this place. And I'm told that we can run these a moment to plug stuff in, so we'll let them do that. But since it's a blank screen, try to see it. Oh, you're gonna plug in here. Okay. Who's got an AI joke?
Hi.
That's the magic box. Whoa. All right, we're on. All right, my name's Andrew. I am from NeuBird, and I want to talk to you about an Agentic AI SRE solution. And if your job title is on there, don't throw stuff at me. Just wait till the presentation is over, and then we can talk about it, right? You can reach us at NeuBird.ai, and in this session, I kind of want to open the discussion about what Agentic AI means, and look at how our product fits in that Agentic AI space and how we function. So I think this kind of is more of a learning experience for kind of everyone, because Agentic AI, really, how new is that term? When's the last time you've heard it? Right. For me, it was, I don't know, 6 months ago or so. I don't know about you guys. It's a fairly new concept. So I kind of want to throw that question to you and get an idea of what you think of Agentic AI. What do you think when you hear that term? What is your perception of what it should do? You can shout it out.
You should not RM-RF without explicit permission.
Okay, don't RM-RF without permission. So with permission, you can, huh?
Well, asking would be nice.
Debatable, but asking would be nice. Okay, anything? What's the? Yeah.
Is it maybe giving the LLM real-time capabilities?
Real-time capabilities. Okay, so it needs to take some agency on your behalf and act in real time, respond to something. Okay. Any other?
I guess it takes on a role of a certain kind of a job role.
Takes a certain job role.
Yeah.
That sounds dangerous. That sounds like it's taking our. Sorry.
It analyzes the inputs
Okay.
of the environment and accordingly takes action.
Yeah. Good. So none of those are wrong, right? And the way that we define it is that an agentic system should be able to plan, respond, and act in a very complex system. So if I say to you, like, I want to build an e-commerce application, what comes to your mind? Is it the infrastructure you want to host it on, AWS, and maybe I want to make it a microservice because that's the cool thing to do. And then I need to use a database. What do I choose? And then how big should the database be? Maybe my e-commerce is a physical good that I store in a warehouse, and the warehouse is everywhere in the United States. So my app should account for that when I take an order, right? So all those things, you're planning and reasoning, And then you need to be able to converse that. If you're using LLMs, just pure chatbots, you need to converse that idea back and forth, right? Whereas an agentic solution should do that on your behalf. So it should have a high-level goal, and it should be able to operate autonomously to pursue that goal. That's what we define as agentic solution. And so in this presentation, we'll look at how NeuBird addresses these points and how we implement that solution, right? Now, on the topic of pursuing things autonomously, it needs to do it in steps, multiple steps. You can't just build a fully functioning e-commerce website in one go, right? So it needs to plan for itself, it needs to execute those actions, and to do that, it needs to connect to an API of sorts, or interact with tools. And then it should tell you what it's doing, so you know what it's creating and what it's not deleting, right? In our space, in NeuBird's world of SREs, there's a lot of cost to downtime, right? So organizations spend a lot of money in addressing downtime. So when we look at why that is, it's because the IT stack is really complex. I think most of us here know what this looks like in practice. You probably worked with a lot of these tools already. Maybe if you're a small org, you start with maybe 1 or 2 clusters of Kubernetes, you put some alerting on it, and life is good. And then your organization grows into an enterprise. And then different people join your organization. They have different preferences. They have different tools that they want to use. A VP comes in and says, hey, we need to use this tool because we saw value. I saw value in the previous organization. Now we're going to go implement this one. Okay, that's how this sprawl kind of happens. So all these different things, they produce data. And then that data goes into some telemetry tool, and then it needs to be stored in the database. And then we want to, visualize it to make sure that you can see the pretty graphs and say, okay, so this is green, this is working good. When I see red, then we panic. I'm going to go dig into the logs now. Right? So there are too many layers of complex telemetry. And with that, right, more observability tools doesn't necessarily mean a faster diagnosis, right? You might have a lot of graphs, but it doesn't give you the kind of correlation. It does, but it doesn't give you that thing that leads to an increased time to diagnosis. So according to the survey, diagnosing incidents is the #1 challenge of SREs. And if you're an SRE, are you nodding or shaking your head? I see some nodding. It's probably this. Okay? So that's the #1 challenge. And I don't think it's the kind of challenge that people are excited about. You don't wake up and think, I can't wait to SSH into 10 different nodes and then grab a bunch of logs and try to correlate different tools to make sense of it and generate an RCA for it, right? That's not what my passion is about. Okay, maybe it is. Like someone's out there like, I don't use grep, I use awk. I know what you're talking about. So yeah, maybe that's your passion, but that's not what the challenge looks like, right? The challenge is every second I don't solve this incident, my org is losing money, right? Someone out there can't reach my site. They can't buy my product. And that's a real issue. Okay, so that's the challenge. So it's kind of a heavy burden, if you will, when you're facing this incident. So the way that we address this is what we're seeing with our customers is that we reduce the mean time to resolve the issue by 80%. And we do this by creating real-time RCAs, root cause analysis. So someone mentioned, it needs to be agentic AI needs to be able to act in real time, right? So real-time RCA. So your starting point of tackling the incident is different, right? With the traditional tools, you start from what? Incident analysis. You look at the incident that's come up, maybe on PagerDuty, and then you start to dive into the details of that incident. Whereas with Hawkeye, which is our tool, with Hawkeye, you start from the root cause and you start from the remediation steps, right? It gives you a summary of what has gone wrong according to this incident and all the data that it's been able to look at, right? And then it gives you the root cause. So it significantly reduces the mean time. And then our customers are able to save money, and with that kind of newfound time, engineering time and money, you're able to invest that elsewhere to more forward-looking projects, like preventing those incidents from occurring in the first place. So if we look at kind of where we sit, we call it the incident resolution backplane. And so you look at the top, what's great is that Hawkeye doesn't upend your existing workflow, right? You might have a system and a team that works great on the tools listed up there. Okay, so we're not gonna ingest any data. We're not gonna take any data and make you, transfer all your stuff to us. We're not gonna say, you can't use these tools, it's not compatible. What we do is we connect to the various tools and we read data from it. We consult the LLM for reasoning power, and then we're able to extract RCA. So we'll talk a little bit more about how it works as we look at the demo. But you'll see that the incident will, for example, come from PagerDuty, okay? And it'll go to Hawkeye because there's a connection to PagerDuty using the API keys. Then, from that, in the Hawkeye, you can instruct it to say, only look at critical severity incidents. I'll handle everything else, you look at critical stuff. Okay? So then Hawkeye, when it sees a critical incident, it takes the metadata of the incident, it'll consult the LLM. It'll say, hey, I have this incident, how do I go about solving it? So the agentic portion is that it's going to reason with the LLMs to come up with the next steps. It's going to ask more and more questions, and based on the result of that question, it's going to ask another question until it goes and finds the root cause of that incident. Okay. Another important point is that you look at all of this, and that's kind of a very precious thing in your organization. You might have data that's confidential, you might have different things that you don't necessarily want to give to the LLM, right? If you thought, oh, I can do this by just passing all the data to Gemini or ChatGPT, right? Why don't I just take all of my telemetry logs and just shove it down the pipe, right? And then I'll get something back, right? So I encourage you to try that. Try to shove terabytes of data to the LLM and see what you get back, right? So you need to be very strategic about what you choose to retrieve from the system. So that's kind of what Hawkeye is doing in the back to get a precise response for that particular incident. So we also have a notion of a runbook. See on the bottom right is a runbook. So a runbook in an SRE world is what? Who can precisely describe runbooks for us? Any volunteers?
Precise. Plan of action, how to mitigate.
Plan of action. How to mitigate stuff. Yeah. Steps you should take in a particular scenario. Maybe there's a pod crash loop back off, and then it's like, okay, I can look at this runbook, and then it'll tell me the steps to take. Nice simple. So with an agentic solution, how should we create it? We should create it automatically, right? Agentically, and decide what the best steps to take are for that particular incident. So we'll do a demo, and we'll hope everything works, the Wi-Fi works, and the demo guys are with us, and that would be great, right? Let's move this full screen. So I'll go to the home page. You all see that okay? Is dark mode okay?
Yeah.
Okay. So this is Hawkeye, and it's very simple, right? There's a home page, there's a projects page, there's a connections and users. So we'll first look at connections. So this is where we define the various, we'll just call it API endpoints, how to talk to these various tools. So we already have AWS and PagerDuty configured, right? So AWS is where all my applications are, PagerDuty is where I get incidents from. Okay? So if I click New Connection, you can see that we have various tools and connections available. The big three clouds, Amazon Azure, Google is down there somewhere, Datadog, Splunk, and GitHub, and so on. So you choose the tool that you use, let's say PagerDuty, and then you define the API keys. So here's my account, go connect to it, right? Once you define a connection, we'll go back to the projects. You'll create a project. So a project contains, you define a number of different connections for, let's say, different applications, right? So we'll go into one, we'll just create a new one actually. We'll call it BayLISA. Click next. And then you can see that the connections you defined earlier shows up here. So if there were more, you would select the one you want to choose for this project. And then click next. And in here is where we can give instructions to the agentic system. You can tell it how to investigate an incident. So in this default example, it says investigate any incidents that are of critical or high priority or severity from any source. And what we see with customers, if they have multiple sources and they just want to investigate one thing, then they specify it here and say, just investigate PagerDuty incidents. Okay, not, some alert manager. So you do that, you validate the query, and you save it. Okay, so now within this project, I have the alert section and investigation section. So when an alert comes up from PagerDuty, it'll show up here. It'll automatically investigate that alert, and then we'll see what that looks like. So to do that, I'm going to use one of our internal tools and click this shiny button that says initiate failure. It's going to go and create some pods and then simulate a failure that we can pick up through PagerDuty, which then gets picked up by Hawkeye to show you. Okay, so we'll let that run a little bit in the background to generate it, and then we'll come back in a little bit after a couple more slides. All right, somebody earlier asked about deployment options. So we have two types. SaaS is what it sounds like. Basically, we'll give you an account, and you can connect your things to it, and everything is included in that price. So all the inferencing that we do, we're going to do in our cluster. It is SOC 2 certified, but the enterprise customers would want to utilize bring your own cloud. So I think with AI security, it's kind of the Wild West now. I don't know what you've been putting into your LLMs, but there's people are putting in things that they probably shouldn't be putting in there, right? Especially the public versions. So with our developments and with any agentic AI developments, I think security needs to be at the forefront, especially because it's such a new technology. So in this bring your own cloud model, we're going to deploy in your own VPC. If you're using AWS, that's your private cloud, your private network in AWS. We also support Azure deployments as well, right? So if we look at that example without going too much into the arrows, we'll use your inferencing cluster of choice. So with Bedrock, you can just choose which models you want to use, and go into Hawkeye and choose, hey, I want you to investigate using these models, and we'll use that. Okay, but we're using your cluster, and no data is going to leave that network, which is very important for us. Right. So when we're looking at this data, and when data is traversing between Hawkeye and your cluster, we're not going to make that leave the cluster to come to us. I'm going to leave that up there for a little bit, but are there any questions at this point before I go back to the demo?
Yeah, what are the hardware requirements for the bring your own cloud?
What are the hardware requirements? I don't know the specifics of the VMs that we deploy, so I'm not sure exactly. But
Okay.
Well,
I mean, you have to run them somewhere.
yeah, and you pay for it presumably because it's bring your own cloud. So we have actually just a licensing fixed cost, but I'm not sure what exactly the requirements are.
Okay. And you guys have your own LLM then? Is that...
No, so we don't have our own LLM. We use just the industry standard, whatever is new and works well for us. So for different types of queries, we'll choose different LLMs for different purposes. The short query, we'll use a smaller model. If it's a larger kind of investigation thing that we need to do, we'll use a bigger model. But we're not training. We're not in the business of training our own models. Okay. So let me talk a little bit about the architecture, just a high level. So when an incident comes in, we need to consult with the LLM to get the logic of how to tackle the incident, right? But what we're not passing in is your data, right? All your telemetry data, we're not passing in. The logs, we're not passing in. What we want to get from the LLM is how to query the backend, how to query your AWS, how to query your telemetry backend. So we are asking it to program a query so that we can take that query and then read your data, so that we can do some logic on it to interpret what steps to take, how to solve this issue. And after that, when we need to consult the LLM again, we'll retrieve some metadata information, and then we'll consult the LLM again. We say, how do we tackle this problem? We have this result. We have this metadata. I want to fix it in this way. So we'll get the next response. So when we look at the demo again, and it comes up with the solution, you'll see the different chain of thought that it went through. So if you're curious how it works, we can look at each of the chain of thought to see what it is thinking and how it solved that issue. Was there something here?
Yeah, so your request was high-level incidents, right? It was very conversational.
Yeah.
So what is it based on? Tags, priority levels, is it sentiment analysis? How does that know what it's talking about?
I don't think I'm qualified to answer that question. It's the model, right? I don't know, to be honest. It's a large language model, and it interprets it in a certain way. To ask one of our engineers.
How about we flip it? Can we specify in that query to say certain severity from PagerDuty or certain severity from the source to investigate?
Yeah, exactly. That's exactly what it's intended for originally. So that's what it's good for. There are other instructions you can pass in, like architectural diagrams. Because inevitably you'll have very specific and nuanced application details that you may be discussed on a whiteboard or something. You basically take a picture of it or draw it out, and then you can pass it in. It'll interpret it and come up with a textual instruction for that diagram. And then next time it investigates, it takes into account that architecture, right? Oh, this app has this name, it's running this particular database, it makes these API calls. It has more contextual understanding of your request. So I'll make sure to show that as well. Yeah.
So how do you scale when you have billions of events coming in from the sources, and
How do you
now
scale?
you want to basically digest them, understand them till the time the incident has been already done?
Yeah.
How do you perform? Is it like scaling horizontally? I mean, how does your NeuBird platform scale?
It scales as well as the human teammates you hope to have to address those incidents. If you have so many incidents that you're overwhelming the system, I think you have an issue with the way you've set up the incidents, with the kind of level of alerts that you're bringing in.
Before incident, right? You want to take, say, precursor.
Okay.
Before even incident occurs, I want to make sure, am I going to saturate at the end, right? Or basically, even get the saturation point. I wanted to start at, say, 60% of my saturation, rather than 80% is no for me, right?
I see.
So you start getting, say, we have thousands of nodes, nodes actually, where our application runs. Everyone sends basically their monitoring stats.
So we're not monitoring individual pods or VMs or anything like that, right? We're only acting on incidents that occur in a particular monitoring tool. So if it's PagerDuty, whatever incident that comes up is what we're reacting to.
So there is no preventive, rather than, I would say, post action is what NeuBird is trying to say. It's triggered.
Yeah, it is.
Triggered.
It is triggered. We're not actively monitoring everything in your deployment, right? We're not trying to be that real time. We're trying to solve the scenario where you're spending money on incident resolution. That's what our focus is. Okay? Maybe we'll expand it, but that's a really big problem. I think you kind of imagine that in your head, and I think you're right. It's a really big amount of data you're ingesting, and then that cost will be enormous.
So you talked about RCAs and runbooks, right? Does your tool also provide like an executive level summary, like per quarter, yearly, just so you can see how well your operations is working?
Yeah, that's a good point. I don't think we have that built into the tool. I'm sure we have something that gets metrics, but yeah, we don't have one where you can say 1 year view and then give me the incident summary.
Can you estimate the cost per month for your own cloud, assuming that there's no incident that month?
Assuming there's no incident.
Yeah.
So if you look at the AWS marketplace, we charge a base rate, which is 2,000 hours. And so we charge by the amount of incidents you investigate. So an incident may happen, but it may not automatically investigate. In that case, we won't charge anything for the license. But you'll still be running the cluster, right? You'll still be running some inferencing, and you'll still be running some stuff. So you'll have that AWS charge. But we charge for 2,000 hours. So if you I don't know the exact number for that, but if you go on the AWS marketplace, we're on there, and it should say what the cost is. Yeah.
So if I understand correctly, earlier you said only when an incident happens, it analyzes the logs and gives a summary of what could have gone wrong. So there is no detection of a potential event happening in the future.
There's no proactive thing that we are doing automatically to detect future events. But the thing is, you can also ask it questions, right? And it'll perform the same type of incident analysis. So if you ask a question, it'll go through that same chain of thought. It'll consult the LLM and say, how do I address this question? And look at the various sources to see, how to best answer that. So it'll do that too. And that way, you are the one that's preventing that future thing, but you have to ask it the right questions. Right?
So could you make it more chatty in your ticketing system to get maybe to that point where you say, for example, tell me more often about bugs to space warnings, stuff like that. You even trigger some low priority tickets that, hey, I'm down to 20% storage, do this will resolve. But you know what I mean? And then could it then absorb that?
So you mean,
as far as,
let's change the threshold of the alert to be a little more chatty, aggressive,
Chatty, yes.
like you say. And that way it'll investigate those and then come up with solutions like, hey, you need to change out your disk. Right?
well, I guess what I'm getting at is, would it be something where it develops a storyline or narrative that, like the point being, like at some point stuff starts falling over, let's say, right? And it's like, oh, well, NeuBird saw these tickets before about the storage going, like the capacity dwindling. I don't know, maybe I'm making up what this thing can do, but.
Yeah, thanks for the credibility. I think it's important. We're pretty small. We're a small organization. But I think it's important. I asked the same thing, a similar thing to the founders, right? Why don't we do this? Why don't we do that? But I think they have a vision in which this is the space where incident response is the space that we want to focus on and address. And that's our top priority. We do this right, we'll do the next thing. Right? So that's kind of our vision right now. And I think it's a good one. I think it's one that's working. So that's the answer I'll give you. Okay? I think, and I hope the thing is ready. So on the right side, you'll see that I've triggered a simple crash loop backoff incident. So you'll see that here, and it tells you a particular namespace. This is just the alert from the PagerDuty, right? So if I click it, it gives me a summary, okay? And it tells you the status on PagerDuty on the left, which is open, and then completed is Hawkeye saying, I have completed my investigation of this incident. Okay. Now the ID then points to PagerDuty, so that you can go there and say, okay, I looked at the RCA, I took the remediation steps, this is now closed. Okay. So you can do that. Now if I look at the summary, okay, here's the root cause analysis. So it goes in and says, okay, this is what I'm investigating. It's in this namespace, HDM BombBird, for this particular container in this cluster. This is what happened caused by the exit1 command. Looks at the, it gives you an incident description. So if we look at the timeline of the events, it tells you that container exited, nothing that new. It's you can gather this by looking at the logs. If we keep going down, it gives you the root cause. So this app was configured with the command exit because that's the way we wrote it to trigger the events, okay, which then caused it to exit immediately with a non-zero. So it's saying that the corrective, it's also giving you the corrective actions, which is to update that container start command. So it'll point to exactly what you need to change, in this case, some YAML file, to take remediation actions for this particular incident. Okay? And then it suggests some more things. You should enhance the logging configuration to get more data. And then proper logging to ensure rapid troubleshooting and root cause identification. It also at the end gives you kind of a summary of time savings it expects. So with a manual human incident investigation, logging into the nodes and retrieving the logs and that type of thing would probably take about 3 hours, whereas Hawkeye took 5 minutes to investigate this incident since it came. Okay. On the left side, there's a download button, and maybe this is kind of, the report to the execs, if you will, looks a little better than this page. So you can download it. It also tells you the sources. So if we click sources, it gives you the name of the log files it consulted, it read from your cluster to be able to answer your question. Okay. Now, the fun part is, actually, let's look at the download first. Okay. So it's the same thing that you saw just now. It's just in a PDF format, and then you can pass it along. So going back here, the fun part is looking at the results page. So this is what the Agentic AI is thinking about. Okay, I have this incident. I'm going to ask this question, and based on the result of the question, I'm going to ask follow-up questions. Okay. I know it's a lot of text here to read. Later if you want to look at it yourself, I'll keep this open so you can scroll through it and interact with it. But on the left, you can see 1, 2, 3. These are different kind of levels, or we can call them runbook steps, right? Each step is asking a question. It's coming up with the question. It's asking a question. And then based on that result, it's asking a follow-up question, right? Until it solves the incident. Okay?
What happens if it can't?
What happens if it can't?
Ask a bunch of questions and just, will it eventually stop? Is there a threshold above which it says, okay, this is too many questions, I'm getting nowhere?
Yeah.
No, it's gonna hallucinate that.
Yeah. It's not going to hallucinate, but I don't know what happens, to be honest. Yeah.
As a human,
Yeah.
right?
Yeah.
You'll go through it and it could be like, this seems like I'm out the weeds, let's.
Call the next level up.
Yeah.
I don't know, actually.
Will this analyze source code?
Will this analyze source code?
So say you have, like, in this case, you have exit 1 because it's in the Docker file. What happens if it was in your application code, it crashed?
Yeah. So
And if you get the source code, would it be able to say, okay, it crashed in this line, or you made this error, or how far deep does it go in that regards?
yeah, you connect to GitHub, and then it can read your source code for that much.
Okay, and it can actually diagnose bugs in your stuff.
It'll correlate between the source code and where it's running in the cluster. And then it's able to say, hey, you need to go into this source code project and then fix this particular line.
And It will pass it on to cloud basically, and then take that and show it to you.
All right. Yes.
All right, so we're on Skynet. Why do you need me then?
Why do we need you?
Yeah, you have the answer.
So who's gonna take the corrective actions? No, it's not. That's not gonna do that for you.
Ah, I see.
It gives you suggested answers. So the automated part is the incident response. It gives you the root cause analysis. Okay. You take that analysis and say, is this accurate enough? Is this enough to fully resolve everything, all the errors I'm seeing?
You're wrong, bot. Shut up. You do that.
No, our bot's not going to take action on your behalf. In fact, when you make the connections, it's read-only access, right? So when you give the API key, we say give it the read-only access. So it'll never act in your cluster like a rogue machine and say let's delete everything.
But you could have a roadmap item that you could actually ask it to act, right?
Yeah, I think that's possible. It's not really my place to say that
Yeah.
there should be.
The point is, if I'm hearing it correctly, it's keeping the human in the loop here. I mean, the SRE is the human in the loop still.
Yes. Yeah. Because you still need to respond to it. You still need to take that corrective action.
Just reboot the machine.
All is well again.
There will be a day where this is smart enough if you take the appropriate.
I think if we look at AI in general and we think about AGI,
Yeah.
right? I think there will be a day where things unimaginable today will happen.
Yeah.
I don't know what that is. I don't think many people know what that is, but there will be some interesting things, and that's just my opinion, right? But in the meantime, we're going to use what we have and solve it in the way that we know how. Yes.
You go through millions and millions of log lines or logs in different log formats. What is the most difficult part to parse that stuff?
What is the most difficult part? I don't think we read the magnitude of millions of logs, because when we consult the LLM with the plan, we consult to retrieve the code to read from the logs, read the particular logs. So we take the incident data and say, hey, I have this incident, crash loop back off. What logs do I need to look at? The incident will tell you what cluster it's at, what, potentially what pod is wrong. And then the LLM will say, you need to go look at these pods. So that's the only thing I need to retrieve. I'm not going to go read my entire sea of logs, right? I'm going to read a particular one to get the relevant information. And then I can look at the pod logs. And then I can look at source code and say, hey, this is what's wrong with my application. Yeah, so we're not reading that many logs. Yeah, if you look at the sources, if we go back to the RCA, look at the source, this one read 15 logs to find the answer. Right, so it's a number of logs, but it's not in the magnitude of millions of logs. Okay, is there anything else?
It's not wasting its time trying to figure context. It's already got context, right? It's set down a particular path, so it's not needing to look across 1,000 pods. It's going to the specific pod that has the problem, and then looking at has context, right? And that's the whole point. Am I understanding correctly? That's why you're not looking at crap tunnels.
Yeah, I think partly. I think an incident can be more complex than that sometimes, and it does need to look at more places. But the starting point is the incident, and the incident data is what I have to work with. So if you had that and you needed to consult the LLM, what would you ask? What do I do with this? How do I solve this? But hopefully you get more in depth than that, right? Where do I go? What commands do I need to run?
So then is it true to say it's only as effective as the incident information? I mean, like the old saying, garbage in, garbage out. If you've got a garbage incident, you're not going to do a whole lot with it, I'm assuming.
Yeah, I think if you have a poor starting point, it would lead to a poor result. Yeah, I think that's probably possible.
Okay, it's your monitoring system and your alert messages and everything. If your alert messages just say, problem happened, site down.
Yeah.
That's not gonna be able to do much more with it than human beings.
So actually then, the observability stuff, monitoring stuff is still of super importance for this to be, like, usable. If you didn't get that part right, then you're kind of screwed.
Because it's triggered, again, it's not it's not Splunk, so it's not
Exactly.
processing everything you're throwing at it. It's just waiting to be triggered, and then it goes looking at specific.
Speaking of that, I noticed you guys have an integration with Splunk. What do you guys do with Splunk? I'm just curious. I do Splunk, so I'm kind of curious.
Yeah, similar thing. We go in. It's one of our.
It's a source.
It's a source, right? So when we need to consult it, we'll consult it and get some information from
So first time you help in incident resolution. So you have the data, you have the knowledge. After 5 days, similar incident occurred. So do you revert back? Oh, there is a similar incident occurred. Here are the steps. So this, initially you took say 20 milliseconds or 5 minutes here, right?
Yeah.
The next time would it be like in few seconds?
It's a great question. So we do have in the vector database, we store past incident details. And that way, when a similar thing occurs, we can refer to it. And that's one of the first things we do. Refer to it and say, have we seen this before? So we're not stupidly running through all the process of retrieving the logs and looking at them. So we store some information there to correlate events. Let's say, hey, this is similar, right? It's a similarity search. So we say, hey, it's a similar thing that happened. This is how we saw it. Okay. Anyone want to throw more freebie questions at me so I can describe more features? All right.
What about the systems that are self-healing?
They're self-healing.
Because one time you say it's failed,
Yeah.
then it's self-healing, it's building itself somehow, and then your analysis is correct or whatever, but it's useless in this particular case.
So what is this self-healing service that I can use today? I don't think there's many, but I mean, I think you're right. I think that's a good approach and say, hey, I'm AWS. I have a bunch of customers. Why don't I just make self-healing machines, right? I think that's a thought. And I'll go back and say that that's not the approach we chose to take. The approach is that we're going to resolve incidents because that's where we're seeing the most impact that we can make today, that we can sell today, that many customers have already today with seeing value as quickly as possible. So that's kind of where my head is at. But I think when we talk about AI, we kind of devolve into this thing where it can solve so many different things, right? What's the point? What am I even working for? But if we do that, we're going to achieve nothing, right? We're just going to sit here and just melt away into a blob. Yeah.
I think in this particular case, so if I had a system that was self-healing, right? So there's an incident, something broke, it fixed itself. Well, that's a different kind of alert, right? The event that you get from that is different. So that wouldn't be something that Hawkeye would pick up. Right? You wouldn't send that to Hawkeye. That would be tagged different. You want to know that it happened, but the site didn't stay down, and so there's no point in spinning up a tool to investigate and try and
It sounds like
tell people to go fix something.
people that know off,
Yeah,
like nothing to see here.
you want that report for sure, because that
Sure.
right, that's part of your metrics. But in terms of the incident itself, it doesn't need human interaction. This tool is simply making the human interaction a little more efficient.
Great take. Thank you.
One more question.
Yes, go ahead.
What about the IoT or industrial environments, not just cloud? Because there is similar things, you have a number of robots doing certain things and then something happens. Machines are worn out or something.
I'll relay that along to our founder. Maybe you want to pick that up. And we don't have that kind of a connection.
Okay.
Yeah, we don't have connections to that.
Can we talk a little bit about what happened?
Yes.
So basically, PagerDuty fire off an alert, has a connection to it, it's aware that it matched the criteria for all I need to investigate. There's a bunch of metadata associated with that incident, and Hawkeye fed all that to its LLM, the model, right?
Yes.
This happened in PagerDuty. What do I do? And the LLM like parses that information and go, oh, looks like there's a Kubernetes issue going on in here. There's some information about that. You need to go talk to this AWS cluster through this connection, and this is how you do it, and go dig up logs, read the pod spec or whatever, and it goes and does that, returns back with, oh, this is the config, something like that, like, oh, there's an exit 1 in here. The model's like, oh, that's bad, you should do this. Like in a nutshell, is that kind of what's going on?
Yeah, I think you described it correctly. So when we talk to the LLM, the response we get back is a query. We actually have our own API system that we developed so that when we get the query, it's an accurate one that we can take to any of our underlying sources that we have connections to. So that's kind of a proprietary system that we developed so that the result of the LLM is accurate and that we go to the right place. Right? So we have that kind of abstraction layer, if you will, a magic box that says, when we go talk to the LLM, the result should produce this. And this should go talk to all of the connections underneath. Right? So that's kind of different than what you described, but it's generally how it works.
And did you say earlier that you don't develop your own models, so you're using...
We're not training any models, we're not developing any models.
So these are models that understand how to troubleshoot Kubernetes, for example? Or what? Or are they just like large language models?
They're just large language models.
And parse English sentences and whatnot?
Yeah. Just your llama, whatever's out there.
So the smart bits for it to figure out like, oh, go read these logs, where's that coming from?
So that's Hawkeye saying, I'm gonna go read from this endpoint and then retrieve it and then analyze that log output to see if I can solve this incident. So that's Hawkeye doing that.
Okay. And then do you release like updates to those models as there are new ways of doing things?
We're not updating the models, but when there's a newer version of the model, we may make it available after testing. We could say, hey, Llama 3.x is better than this old one, so let's use that newer model. Yeah.
And for situations like people have applications that fail and fire off, alerts, said, oh yeah, we can have a connection to like GitHub or something like that, a repo. If we have existing runbooks, can it read that in and take that into consideration?
Yeah. If you have existing runbooks, there's a particular place where you can pass it in. So if we go to instructions, we go to add instructions, you can see that there's an instruction for RCA doc. And this is basically, I have my own template, I have my own way of creating an RCA. Here's how it's done. Here's an example RCA. You make it the same way.
Okay, so you can format your RCA. That's fine. I was referring to like how to troubleshoot a PagerDuty alert that would come in for your application. So maybe it's like, oh, we need to see if this metric's gone haywire or whatever. Compare, is this also crashing? So unique to your environment, and you have a runbook, can it feed off that?
No, it's not going to investigate based on your runbook. It's going to produce an output that looks like your runbook. So it's not going to run through your runbook.
Okay.
Right? Okay. I think I fielded a lot of questions, and I just, as a closing remark, I'll just say, if this sounds interesting to you, or if you just want to talk to me, you can reach out. I'm at Andrew@NeuBird.ai. I showed you the links before, NeuBird.ai. Just go and you can contact us if this is interesting to you. Just want to say hi. You can reach me there. And I want to thank you for coming out again. Thanks for having me out there and hosting the event. And yeah, I'll be around. Thank you.